Okay, good evening, ladies and gentlemen. This is Professor David J. De Los Reyes. What I will be discussing tonight will be the concept on how to use a Zener diode, which is to be used as a voltage regulator. Zener diode can be used as a voltage regulator. It is this one here. It is this one. That's a Zener diode. But Zener diode are actually used as a voltage regulator for discrete components like a 10-pin IC maybe, which does not consume so much current. But in electronics, the voltage regulators used for discrete components are actually, one is actually a Zener diode, this one. So for tonight, I will be, assembling. I will assemble a Zener diode that will act as a voltage regulator. And let's try to see if it will really give the required voltage for that Zener diode. What I will be doing the assembly tonight is this diagram here. The input voltage will be 21 volts, but on my actual diagram it's 19.52. And the Zener diode that I will be using will be the output of this Zener diode, meaning the voltage across this is 12 volts. So this Zener diode here is actually a 12 volt Zener diode. One of the requirements for a Zener diode to act as a voltage regulator is that I got some discussions over here. Okay. The voltage drop across the diode is constant. The supply voltage must exceed the Zener diode for this circuit to operate. Meaning to say, if we would like to bring out a 12 volt voltage across this, we will be using a 12 volt Zener diode. And the DC input voltage must be greater than the breakdown voltage of the Zener diode. Meaning to say, we could make this Zener diode as a voltage regulator for as long as the input voltage here will be greater than the required output voltage of the Zener diode. So if we try to input 21 volts, we could bring out a 12 volt across the Zener diode. And one of the requirements for a Zener diode is that there must be a series resistor here. And for our example for tonight, this RS, meaning series resistor, is actually 1K. So what I did, guys, is that I don't have the exact 1K. So I just add up a 820. What's this one? Yeah, I add up an 820 and 180, and the total of that will be 1K. So the series equivalent of these two resistors here is actually this 1K over here. Okay. I got an adapter here as a power source to the Zener diode. The output voltage of this one, this is not regulated. The output of this one is around 19.27 volts DC. It's unregulated. So 19 point something volts DC. So we changed this 21 to 19 point something. Anyway, 19 point something is still greater than 12 volts. So if we try, in order for this Zener diode to act as a 12-volt regulator, it will work because this 19 is greater than this 12 volt. Okay. So what I did now is I plug in the adapter. The output of this adapter is actually registered by this first multimeter here, 19.27 volts. So this is 19.27, it's not 21. And I tap a DC voltmeter across the terminals here, across this. Okay, it is actually this multimeter here. Okay, and the measured voltage across the Zener diode is 12.29. Okay, like what I said, the Zener diode I use here is 12 volt, and supposed to be it will bring out 12 volt or a little bit greater than 12 volt as an output. And as a proof to that, the voltage across the Zener diode is 12.29. You see it, guys? The input voltage of the circuit is 19.25. Okay. There is a series resistor of 1K here. These two resistors here, like what I said, it's the combination of 820, 180. I don't have the exact 1K. So 820 plus 180, this is 1K. Okay. That's that portion there. And this portion is actually this portion here. Okay. Like what I said, if we try to check the validity of the voltage across the Zener diode, if it is really acting as a 12-volt regulator, okay, because this Zener diode is actually a 12-volt. The voltage output of this one should be 12 volt. And what comes out as per measurement is 12.29. Okay, that's the actual assembly of a Zener diode that will be acting as a voltage regulator. I would like to repeat it. Zener diode could act as a voltage regulator only for those discrete components that does not require high current. The current requirement of the current output of this one may be in the so-called milliampere range. So this is good for a 12-pin IC maybe. For us to stabilize the voltage input to that IC, we could use a Zener diode. Zener diode are not used for high current requirement. It is only used for low voltage and low current requirement. But they could act as a voltage regulator for the discrete component or for that component to operate satisfactorily or efficiently. Because without satisfying the voltage requirement of those discrete components, okay, of course the operation will be different. Or it might bring out a different, efficiency, or it will not work maybe. So in electronics, it's a must that if a discrete component needed a 12 volt voltage across its input, we should at least input a voltage equal to that or a little bit greater. A little bit less than, it's fine, but it's not too low for it to operate. If the required voltage is 12 volts and it so happened that the voltage input is 12.29, that's fine. But just in case it will go down to 11.5, there might something that will happen to the operation of that discrete component. Okay, that's it, guys. That's how we analyze the concept on how to assemble a Zener diode. And like I have shown you the actual circuit now. Like what I said, the voltage input to the Zener diode is this adapter here. The output of this one is 12 volts. No, 19 volts. 19.39. Okay. And the voltage output across the Zener diode is 12.29. So actually, Zener diode could act as a voltage regulator. Okay, good evening from Los Angeles. This is Professor David J. De Los Reyes.